All right, let's jump right in. We're going to look at two very different animals from totally opposite ends of the ocean. First, you've got this tiny, delicate pipefish living in the sunny shallows. Then, way down in the crushing dark, there's this mysterious deep-sea shark. You couldn't find two more different worlds, and yet they share this incredible biological secret, one that actually ties their fates together.
Okay, so our story kicks off right here, in the beautiful, sun-drenched eelgrass beds off the coast of Norway. This is where we find our first character, the broad-nosed pipefish. Now, this place looks pretty self-contained, right? A world of light and shadow, but this is where we find the first clue in a much, much deeper mystery.
But here's the thing. To really get what's going on with this little coastal fish, we can't stay on the coast. No. To solve this puzzle, we have to leave all the sunlight behind and just plunge thousands of feet down into the abyss. It is a completely different universe down there. Cold, dark, immense pressure. And it's where we'll find the missing piece of the puzzle.
So what on earth could possibly connect these two? I mean, a tiny fish that never leaves its neighborhood, and a big predator that prowls the deep sea. Well, the answer reveals this fundamental rule of biology that has huge consequences for survival across the entire ocean.
So let's start with our first piece of the puzzle, the pipefish. We're calling it the stay-at-home fish, and for good reason. See, some scientists in Norway were really curious about how it and other fish get around, and what they found was, honestly, pretty amazing.
This all comes from a really cool 2022 study in the journal Molecular Ecology. Researchers were basically using genetics to figure out how different fish populations mix and mingle, to see which ones are the big travelers and which ones prefer to just stay home. And what they found is that in the ocean, there are basically two main strategies for having kids. You've got the drifters on one side. They just release tons of tiny eggs or larvae and let the ocean currents do the work, spreading their genes all over the place. And then you've got the homebodies. They skip that whole drifting phase. Instead, they give birth to these fully formed little juveniles that are ready to settle down right where they were born.
And our broad-nosed pipefish? Oh, it's the ultimate homebody. It's not a great swimmer, so it tends to stick to its little patch of eelgrass. And get this, it's the dad who gets pregnant. He carries the eggs in a special pouch and gives birth to these tiny, perfect miniatures of himself that pretty much stay put right away. Now, this stay-at-home lifestyle, it has a massive genetic consequence, and it all boils down to this one number, just 2 kilometers. That's it. That's all it takes. 2 kilometers is the distance at which two groups of these pipefish become genetically different from each other. In the vastness of the ocean, that's nothing. It means that two populations living just a short boat ride apart are basically genetic strangers. It creates this extreme isolation. Okay, so hang on to that idea of isolation. Pin it, because that thought is exactly what's going to take us from the sunny coast down into the deep sea. It's time to meet our second character.
Say hello to the Portuguese shark. This animal lives in total darkness, often more than 400 meters deep. It's a true deep water specialist. So, in this huge, seemingly empty environment, how does it make sure its species continues?
And here it is. This is the secret handshake.
The Portuguese shark is something called ovoviviparous. It's a mouthful, I know, but all it means is the mom keeps the eggs inside her body until they hatch, and then she gives birth to live, fully developed pups. Now think about this. The shark pups are born at 30 centimeters long. That's the entire adult size of our pipefish. They come out ready to go, totally prepared for life in the deep. And just like the pipefish, they completely skip a drifting stage. They are born homebodies. So let's go back to our pipefish study for a second. The scientists there concluded that not having that drifting larval stage is the very thing that creates these deep genetic divides between different populations. And there it is. That's the big reveal. The exact same biological rule is at play. It doesn't matter if you're in a sunny eelgrass bed or the crushing dark of the abyss. If your babies stay home, your populations get cut off from each other. So what, right? Why does any of this matter? Well, it turns out that being a homebody, when you combine it with one other trait that both these animals share, creates a really serious risk. And that trait is this. Both of them live in patchy homes. The pipefish needs these specific, disconnected beds of eelgrass. And the shark? It lives in very particular zones on the enormous seafloor. For both of them, their ideal home is like a little island, separated by lots of not-so-great habitat. So, when you put those two things together, you get a perfect recipe for isolation. Step 1, your kids don't go far. Step 2, the next good home is a long, long way away. The result? You get these really isolated populations with almost no connection, or what scientists call gene flow, between them.
And here's why that's so dangerous. If a local population gets wiped out, maybe from pollution or habitat loss or overfishing, there aren't any little drifters coming in from other places to repopulate. An empty patch is likely to stay empty for a very, very long time.
And that brings us to our final and honestly our most important point. Understanding this kind of deep biological connection isn't just a fun science fact. It's absolutely critical for conservation. Just look at all the risk factors stacked against them. They both have young that stay put. They both live in these fragmented habitats. And for the shark, it gets even worse. They have a really low birth rate, only about 10 to 14 pups at a time. All this makes them incredibly vulnerable to local threats. You can't just assume that if you fish out one area, more will just swim in from somewhere else. They won't.
And this isn't just a hypothetical problem. The Portuguese shark is already officially listed as near threatened. Its very own biology, the way it lives its life, makes it incredibly fragile.
The warnings from conservation experts are pretty stark. They say that because these populations are so disconnected, any increase at all in fishing catches is, and I'm quoting here, a reason for concern. So this secret link between a little pipefish and a deep-sea shark teaches us something really important. The most basic, fundamental details of an animal's life, how it's born, how far it travels, those are often the absolute keys to its survival, which really leaves us with a pretty big question, doesn't it? If we don't bother to understand these fundamental life stories, how can we ever even hope to protect all the amazing and vulnerable life on our planet?